specifications that are required for the particular project, and therefore it is important to have a very flexible partner for these products to take place and carry out. If we are taking a look at the wastewater itself and defining what is wastewater, because there is no actual regulation or classification for the wastewater. We got a lot of tender specifications for the project itself, but there's no real classification for the medium, for the liquid that we are pumping. So there's something indefined that stands there or is there in the air, but we cannot really touch it. We cannot define it. So this is another question mark that we are faced with. And in order to, how shall we define the efficiency in wastewater? Many other suppliers of equipment in the market, they are defining efficiency with a very small free passage inside their pump hydraulics, which in our understanding is not a proper way to handle it. We rather should pay more attention on a failure-free operation and how can we achieve this with larger free passages inside of the pumps, with certain grinder systems, with even some more mixers installed of the pumping station in order to flush around the liquid to get it working properly, and some other flushing methods like flushing valves as well. You can imagine you have a very efficient pump, but what happens to the efficiency if later on the pump is failing? We have to take it to the workshop, you have to implement another time, a lot of money. So once again, we should focus on the complete life cycle and make an total evaluation of the complete process from the beginning until the end. I just mentioned some ideas about avoiding the clogging of the pumps. Some ideas might be another chopper system, even for larger grinder pumps that can be implemented easily. This is particularly designed here for larger or longer fibrous material. So it's another idea in order to cut down the possibility for any clogging inside of the pump suctions and volutes. Yeah, if you take a look at the tender specification, what we have there out there on the market, everyone is asking for reliable and efficiently operating pumps. But how shall we define this, and how shall we find a product which is reliable and efficient? Nobody is telling us, really. So we ourselves, the operators, consultings, and equipment suppliers, have to find like a balance in between the cost-benefit ratio in order to combine low energy cost for the operation together with non-clogging properties of the pump itself. There was a study made by the Technical University of Berlin. They were doing this together with the water operators of Berlin, and they came to the conclusion that a single point view of adjusting the wastewater market over the efficiency value only is no sustainable treatment of the resources. This also wants to tell us that we should focus not only on the efficiency figures on the data sheets, rather than taking a look at the complete life cycle as well. Make an evaluation of the energy cost, of course, for the operation, but also consider the maintenance and repair cost, which is a very large factor if you talk to operators. As I said, we should focus on the complete life cycle. So first of all, make an analysis of the system and the requirement, what is given as a task, then make an optimal and individual selection of all the products. They need to harmonize with each other. It is very important, because if there is, let's say, a very large difference in what kind of pipe size we are losing later on, this might have influence on what is happening inside of the pumping station. As I mentioned before, the hydraulics, they should have excellent rag handling capabilities. The motors, of course, as well, should be as efficient as possible. On the other side here with submersible motors, we need to see that the IE3 premium efficiency standard is not applicable on submersible motors, is not applicable on motors which are included in machines. But on the other side, of course, it is important to try to keep up the efficiency level as high as possible. And also what is recommended, I told about a failure-free operation. So it is very important to be capable to monitor the operation and find out if something is actually not operating in a proper way. So an optimized operation should be given, and there are some tools I will show you in the next slide that can help you with that. After sales service, of course, as well, from all the equipment suppliers as well as distributors in the country should be given as well. So all these factors also should, in my opinion, influence the selection of all the equipment suppliers. As I said, monitoring the operation, therefore there's a possibility available on the market which is not only a vibration sensor inside of the pump, but this is rather a system to monitor the operation and give you a pre-alert, an early alert for a possible failure that might come up in the near future. So there's a acceleration sensor. I don't know if you can point it out here. Acceleration sensor inside this box, which is directly connected to the pump casing. And this acceleration sensor can define or can determine certain frequency spectrums which are given from the motor, which are given from the hydraulic, from the impeller, and this can be determined accordingly, so where the vibration, where the failure is coming from. You can do a long-term monitoring, you can save this data on a memory stick, and accordingly can do a very good evaluation of what is happening inside the pump. And as I said, it's a pre-alert system, so it also gives you the possibility to interact and to do maintenance, to do exchange of the parts, even before a failure might happen to the pump or the motor itself. I think that was it. As I said, a complete focus on the life cycle should be given. And we shouldn't pay too much attention on the efficiency values which are given on the data sheet, rather than to give a complete wrap-up of the complete life cycle cost. Thank you.
Thank you very much, Stephen, for keeping the time. The next presenter is Mr. Amir Mokbil. The topic of his presentation is improving energy saving in water supply in Jordan. Example of water and lib pumping station. Mr. Amir is a sanitary engineer graduated by Technical University of Dresden. He has 25 years experience in general, and he has worked in more than 15 years in different German consulting. He has worked in international management, international sales management for Wilo pumps and mixers. And this is working in the improvement of the repair and center submersible workshops in Zarqa, Jordan. He's also a member of the German Water Partnership. Thank you very much, Mr. Amir.
Thank you very much. So just some technical problem.
Yeah, the link itself.
Yeah. So, thank you very much for your introducing. Thank you very much for your attendance, ladies and gentlemen. What we want to speak today about energy saving, improving energy saving in water supply Jordan, and we take the example Wala and Lib pumping station. Everybody from us here is working in water field and know that water distribution is an issue. What we have a problem, I will just summarize, worldwide problem, increasing the water demand because of standard of living, increasing of standard of living, increasing the population is an issue. And of course, the industry, agriculture, and the urban and special problem in Jordan, the people refugees, the problem from Syria, from the war in Syria, 1 million people coming in one time. Jordan is has a limited resource in water and energy. And in other hand, we have a big water losses in the system worldwide, and we have to look how we cover this gap. One issue and an option, and I am very happy that Mrs. Amal mentioned in his presentation, desalination is an option, but desalination also need too much energy, and always the plan for desalination is far away from the people. You need distribution, and the cost is very high for that. So how we know about the cost? Always we know the cost divided in investment, operation, and maintenance. And we have some sources here for some example for the cost. We know for each cubic meter water, the costs vary between some few cents up to more than $1 per cubic meter. And to pump the water 100 meter is like cost to move the water 100 kilometer. We know about the source of losses. Globally, we have 25 to 30% water losses, and in Middle East and especially in Germany is more than 40%, which is the sources in water is very limited, also in energy. Challenge for Jordan, secured and efficient water supply. If we can do this secured and save energy in Jordan, we can do it in every country, because some point in Jordan are available. Jordan is one of the dirtiest country in the world with high water scarcity. The country has faced more than 40% water losses. The challenge in topography with more than 1,000 high different outdated pumping station with low energy efficiency and high maintenance demand result to low supply security. And 15% from the total needed energy is going in Jordan for the pumping station. And in Jordan is very limited financial resources are existed. Everybody know that is not new. What is the solution? We think about energy saving financing project. Willow developed a special pump in water supply. This is pressure shroud pumps, and with internal cooling, with improving the performance up to the normal standard pump to the up to 25%. And there is special protected positioning of motor and pump. That means safe and reliable operation even under rough environmental condition. And now non-external dynamic seal, that means the water losses is also solved. The problem of water losses is solved inside the pumping station. Compact and robust design, cost saving for installation and maintenance, and not too much space are needed, and the sound of the pump is very, very low, that we can put it inside the population area. We believe in the efficiency of our solution financing model, energy saving contracting. I will come later on to that. Self-financing concept, that means from the energy saving, the project will be cover the cost through public partnership project. The idea is coming from GIZ and from Germany, and the PPP project can be financed, and 1 turtle from GIZ and 2 turtle should be covered by energy saving, in this case by water supply company Miyahuna. So what we start WILO in the idea to implement this idea in Jordan, and we start firstly with training the operator in issues for repair and maintenance the pump. Target was draw up service working plans, optimize the process, and updated quality management system. What we do, we analyze each situation, and we train the people for repair motors and hydraulic. We reorganize the test of facility and stock management, and the location. This is central workshop in Zarqa. That was the first activity WILO in Jordan. After that, we come to the pumping station, and the idea was born by Federal Ministry for Environmental, and I am very happy that Dr. Holzwart is here. The idea was born by himself. I remember 6 years ago, I sit in your office, and you told me we should demonstrate for the people how we can save energy, and we have better environmental condition in Jordan, and started to finance pilot project called Korea Pumping Station. Was fully financed by BMU, the Ministry for Federal Ministry for Environmental. Project management was by GIZ. The public partner was WILO in cooperation with Engicon. Engicon is a local consulting with facility for maintenance and operation of treatment plant pumping station. What was the situation in the Korea? Low energy efficiency existing pump was with efficient only 46%, maybe less than that. And of course, this is then need more energy, and it means more CO2. High maintenance was a requirement, up to 20% water losses. That means not all water was can be used, and low level of supply security. We change the energy audit was by Dorsch Consult at that time. He's identified the energy saving potential not only in Korea but in the country of Jordan. What we do, we exchange the existing pump to high efficiency pump from WILO, designed, produced, and installed and commissioning by WILO in cooperation with Engicon. So Engicon was then the operator and the designer. Engicon experience in the result was 34% saving in power consumption, CO2 reduction up to 90,000 kilogram per month, and 23,000 cubic meter per month more supplied water to reduce water losses. Annual cost saving was 127,000 euro per year, and the total cost for the project was around 300,000. That means in 3 years, 2-3 years, we covered the cost. We have produced some information material for that. If you want, you can take it here with you now. What we do, we continue the success story, and now we are not only in PPP project, we go through energy saving contracting project. The lead was here Engicon. We are subcontractor with Engicon. And the idea is there is 2 pumping stations to supply the water to Madaba, called Wala and Lib. In every pumping station, there is 4 pump with 450 cubic meter per hour. The total head is not 700, excuse me for that, is around 500 meter. So every from Wala to Lib is around 250, and from Lib to Madaba is around 250. Energy saving contracting for Willow part, the cost was 450,000. Our task was to deliver the pump, to supervision of installation, and to train the people and supervision of operation. All civil work and installation and control panel and operation part is provided by Engicon. Actually, we are in the commissioning phase. Maybe we start from the 1st of January with the official operation. Expected energy saving is also around 30%. We will see then in the next 3 years for Willow, the contract, but for 5 years for Engicon. There is here, Mr. Matar is attend here, he presented Engicon. If you have any comment, please, Firas, you can do it. So, and the next challenge is also the desalination. There is no way, we need more water, but before we do to go this way, we have to really to optimize the situation in the pumping station in Jordan, and KfW now go the way to tendered around 15 pumping station and more than 130 deep well pump. So this is what I want to give you today. Thank you for your attention.
Thank you, Mr. Amir. Our next speaker is Dr. Fritz. Dr. Fritz is a former Water and Marine Director of Germany, representing Berlin Water Trade Affair. The topic of his presentation is Energy Saving Technologies at Water Berlin International Exhibition 2015. Dr. Fritz, the floor is yours.
What's your name?
Four, yes.
It's okay.
Thank you very much.
Salam alaikum. Good afternoon, ladies and gentlemen. I will try now to give you a brief insight into the Berlin Water Trade Fair, which is starting on the 23rd of March this year. You got quite a few points now through the different companies, but we think that there is a broader view necessary.